Thanks a lot. It's almost 4:30, but maybe one or two questions are possible if there are any.
I'm a bit astonished that entity recognition is here seems to be a problem here, because usually musical pieces are rather well structured in their reference. I mean, you have a composer, you have the title of the work, you have even the Köchelverzeichnis numbers, stuff like that. So I would assume, as a naive outside watcher, that this is the most the perfect space where you can very easily identify it.
Would expect that too, but
maybe it's my but things like the Köchelverzeichnis are much later. They didn't exist then.
Okay.
So they are mentioned. And for example, Mozart, a better example would be Haydn. He wrote like more than 100 symphonies. So there are several in the same key, like D major symphonies, and there's hardly a way how to recognize what it might be. And the word like symphony occurs so often in the texts that you have somehow to figure out what kind of symphony it might be. It's actually very difficult to define features that make it obvious.
But I would assume that every article, I mean, you are extracting the information from magazines, basically, from journals and so on.
Yeah.
So they are properly titled. So this text refers to this piece of this composer in this key, and this is the title and so on. And then, then I have the perfect reference.
Yeah, sometimes they do, but then it's like this is about Haydn Symphony in D. Very often you don't get more, but more often you get reviews of concerts where they would tell you, well, we heard works by Beethoven, by Brahms, by Wagner, whatever, and at some point we mentioned we had the symphony in E flat by Beethoven also, and so it can be, it's usually much more complicated than such an easy information, unfortunately.
And also the interesting part is that the information is, we looked at some examples, so sometimes the information is spread over different sentences, so you can just find this place, but you have to look at different information and combine them together.
Good question.
Yeah, so you're looking at the context of the text itself, but do you also have to consider the temporal context at the time? I mean, if you have a really long time span, I can imagine that some words might change their meaning.
Yeah, it's perfectly true. We would have to do that, but the first step, we just need access to the corpus as a flat corpus. So we just treat it as being one time span. So just one time. But you're perfectly right. Semantics evolve, but to show that, we would have to choose another setting, which is what I just skipped. This one. That's where funk comes in, where we need something like a slider where you can say, okay, this is the meaning of word X at a certain time, because this is the distribution of pattern then. Then if we go 100 years later, the meaning is completely different. So it's actually what we refer to, and normally I would say yes, we would have to do that. But in the first step, it's okay to just treat it as being the same. So it's just a generalization. You're right.
I think we should stop here and allow a coffee break. Thank you very much.
Thank you.
Again.
Ja, machen wir das mal.
Ja, ich habe schon ein paar Mal geschafft, aber irgendwie geht's nicht. So, da will ich irgendwo unterschreiben auf der nächsten Seite. Okay, da war ich auch schon. Und jetzt haben wir ist da? Ja. Jetzt glaube ich. Können Sie jetzt hier Signatur eintragen? Also entweder
okay,
so
oder per Hand zeichnen. Und dann können Sie die einfach auswählen und einfügen.
Und wie mache ich das, dass man die dann rauskopiert?
Ja, es wird eine neue PDF gespeichert.
Das ist jetzt blöd, ja.
Also das wird eine Datei werden, die ist nicht rauskopiert und die hat eine digital signierte Datei. Das heißt, die Unterschrift ist dann noch als Bild nochmal eingefügt, aber nebendran sieht man dann noch zusätzliche Informationen, wann es erstellt wurde, wer der Inhaber ist und so weiter.
Ich will nur aus dem Dokument unterschreiben, das genauso wie wenn ich es mit ausdruckt und kopiert.
Ja, aber das wäre schon so auch, Sie könnten das dann genauso wegschicken und das würde man halt so sehen. Jetzt hätten Sie nur
So, ich habe das da irgendwie zu dick ist der Stift. Da muss man, wie geht es denn da zu unten? Wie löscht man das denn?
Hier. Sie können das jetzt eintragen und dann kann man die Größe noch anpassen. Geht das? Also das hier dann zu
Original hat es auch schon mal anders gemacht.
Ja, weil wir lassen ihn jetzt genug.
Was ist das? Nein.
Is it already processed with OCR?
It is, yeah. Yeah, it is. So, I mean, if you use it, they just show the text and highlight it, but to do the highlighting, they need the text.
Okay, but we can't offload the scan, the OCR text.
You have to ask them first.
Okay.
Yeah.
No.
So, good, yeah. Okay, so that's about the data. So once we have the data, we can just do those 3 steps, which are to build, to support building semantic fields. The second step would be to identify words. And the third step is then to combine it in a search. So, okay, first of all, semantic fields is to give you a bit more of an idea. As I said, it's just a list of words, and in the end, or in the way we will do it, it will still be a list of words. So it's not about inner structure or something. So in linguistics, you have concepts like the word fields or Wortfeld, which is an old concept which is meant to have something like an inner structure. But we're not talking about this kind of semantic fields, but it's just clusters, actually clusters of words that are similar in the sense that they are in the same topic. And topic here is meant to be defined by the musicologist, so to say. Just expressive qualities are nothing that you can look up somewhere. You can take a lexicon or dictionary and say, okay, I need all the expressive qualities, how music can be described, because people describe it in their own words. So we need something like a heuristic approach to build these things.
So I'm astonished that you mix different languages. If I use this word field, this semantic field, and run it against the document, will you extract the non-language specific words before you run the query?
This is actually, this list is taken from the article about the uncanny, from Financial, and he just listed all the words that he has been searching for. So this is like the manual process, so the full manual process. And we would try to enhance this by adding automatic procedures. So because what you can do is you can just think about what are good words to describe music in terms of, I don't know, if you want to focus on uncanny mean, what are words for uncanny, like synonyms, for example. You could take contemporary dictionaries to look up more synonyms or things that you didn't think of. You could add it by using encyclopedias and stuff. Or you could take dedicated resources like that NRC Emolex thing, which is used for sentiment detection, for example. You could just add it up, and then you have a manual approach. Or you could use things like word embeddings. That very moment, word embeddings are a certain way of representation, like representing words by vectors, basically. So you can get access to their semantics, because if you compare words by themselves, just by their form, they're not similar at all. So you don't know anything about the semantics by looking at just the symbol or the symbolic representation. So, just skip something? Okay, just a bit about the background of embeddings, because we're going to use a certain type of word embeddings, but to get you an idea what the linguistic properties of these are, is that the idea is to represent words just by their distribution of properties. And distribution means like by the way they are used. So there's a famous saying which is that you can tell a word by the company that it keeps, which means like if you say a green book or a red book, then you know that green and red have kind of the same company, so they might be the same type. So that's distribution hypothesis is pretty important for linguistic field of structuralism. So the claim is attributed to Zelig Harris, who's basically an American structuralist who was the teacher of Chomsky. So Chomsky worked against in a certain sense. And he never said that because he actually focused not on semantics, but he focused completely on structure. But those structural properties can be used to infer semantics. So that's the idea. So what we get, if we take this literally, then we get a methodology to build those representations. The methodology is just counting, basically. So as an idea, we just count the words where that other words occur. So say that you can make the differentiation in semantics because of the different distribution of context words that you have here. So for example, apples and bananas are kind of more similar to each other because they both occur together with trees. And they're not so similar to lorry because they will never lorry, which is not quite true, but it depends on the pattern that you get from all the occurrences. So what you have in the end is something like a vector. So vector representations for words. So this is kind of the idea.
So then you take the Euclidean distance?
Sorry?
You take the Euclidean distance to measure the
Cosine distance. Cosine.
Cosine. Because it's
Yeah,
yes. Yes.
Yeah, but as I said, you can project that to a vector space. So once you have vectors, you can project it to a vector space, and the vector space is the reason why it's called embeddings. So word embeddings, because those words are embedded in vector space close to each other. So similar words are embedded close to each other, which is due to this second main assumption, which is something like the geometric metaphor, where you say, I don't know, this is far from perfect, for example, or there's a close relation. You always use this kind of closeness, proximity, similarity, association. So this is kind of a cognitive explanation for that in linguistics. So what we have here is something like a traditional model. So it's just the idea that we use. So we have something like a vector space model where you can represent meaning in terms of positions in space. So you have closeness as a relation that you can kind of mathematically determine. So you have that high-dimensional space. The dimensions just depend on how many context words you would set up for looking at the distribution of patterns. And at the same time, you have that methodology. So it's a pretty neat model, at least from a linguistic point of view. You can say, okay, there's both at once. What you get from that is that spatial representations where you can just measure how close something is, so you can cluster things. And that's actually what we want. We want to cluster things, but the traditional models, there are quite some shortcomings. One of them is that we just have a bank of words, so we don't look at word order, and word order is pretty important for some linguistic properties. And the other problem is that these big vectors are really sparse, so most of the words do not occur very often. That's why we use more modern approaches, which is
yeah, so there's the linguistics, I have the computer science stuff, and the idea is how do we even get those vectors? There are multiple methods, and the current state of the art method is virtual vector, which just works a lot better than others do, because there are certain restrictions that don't apply. One of the main advantages is that we can use a lot of data. So when you try to learn a virtual vector model on modern language, you just take, for example, Wikipedia, all of it, and then get a pretty good idea how words interrelate. Now the plan for us is to work with as much 19th century text as we can find. And the other thing is that we don't count, and instead we use deep learning, which is obviously much better. So how does it even work? So there are two basic approaches. One is we want to know the word from the company it keeps. So we start by taking 5 words in a row and then blank out the one in the middle. And the task for the deep learning is to guess what is the third word. So this is the approach. Now, this is actually a pretty easy task. Like, if I would show you some text and just do the blanking, you would, as a human, would have a pretty good idea of which word would be there. So, for deep learning, we want to have a very difficult task. So instead, we do something else. We take the word in the middle, give that to the computer, and let him guess the other 4 words. And the idea is that we can have more gain in intelligence like that. We can represent more intelligence, because the first task is in many ways too simple. But it really depends on the data that you have, which one is preferable. So we'll probably test both of them to see which one works better. So the skipgram is for when you have really large data, is the one that usually performs better. What we do then is to use a deep learning approach by using all kinds of, like a neural net, and use all kinds of hidden layers, so that the computer ideally actually understands what the words mean. So they have a lot of data, and the hidden layers the idea is that they are actually catching the semantics. Now, can we know that it worked? Well, we have some indications, because we know that the results, the vectors, they have certain probabilities. Like when you think about certain words, you know that some words are more related than others. And what you can see here is that when you have something like a man and a woman, they have like a certain difference between them. But when you want to go from king to queen, you see that it's almost the same vector. So you can make semantical inferences on this vector model, which means that the neural net has actually understood what's going on in the text to some degree at least. Another example are grammatical versions. So it's very clear that the neural net in some way understands how these work. And yeah, something like country and capital. We know that the difference vectors between the two of those tend to be very similar. So how does it relate to our problem? So as I said before, we want to have a virtual vector model that we can actually use. So we have to pick one that uses the same language as our target documents. Now, well, on the surface, that language is supposed to be English or German or whatever. But it's not so simple because language time, and we have the feeling that especially for such descriptive words, that there is a lot of that there are a lot of changes over time. So to make sure that we don't get fooled by some kind of word shifts or semantic shifts in the word semantics, we want to use as much contemporary text as possible. And there are also other people who do something like that. For example, if you want to talk about text from chemistry, then it's better to learn on a corpus that has predominantly text from chemistry. Okay, so now when we have the word fact, what are you going to do with it? Now, the idea is to look for words that are very close together and see if they fit. Now, as I said before, what we're actually doing is that we try to find words that easily replace each other. And one thing that is, like what you said, the green book and the red book, it means that they belong to the same category, but not necessarily have the same meaning in the sense that we are looking for. So what we have to be careful is that usually something like good and bad is pretty close together, but we only want one half of that equation. So we really have to be a little careful. So there is another manual step to really get the best words to add to our theories.
But you can learn that this is the concept of color, isn't it?
Yeah.
Yeah.
The colors should all be in the same region, right?
No, I want to say that they are close together.
Yeah.
You know they have the same type as this color.
Yeah, but there's some particular problems like synonymy, antonymy are kind of the same.
So we are aware that this is not as clear cut as it now sounds. That all the very very similar ones go together, and the other ones.
Some post processing.
Yeah, you need some post processing. So one example that's something we did, but from a friend of mine, she was trying to find everyone who worked in a certain medical field, and then she discovered that nurse and doctor was very far apart from each other, because apparently they tend to occur in very different contexts. So that didn't work. But she could identify different types of doctors.
What does it mean far apart?
Well, it's a vector, and you can calculate differences.
So how is word to vector working? How does it work?
Okay.
What are the dimensions of the vector space to result in the vector that represents doctor? This is your question, right?
Yeah, how to build up that space? I can think of zillions of mappings.
Wow, that's interesting.
Sure, if I do the text, you parse it, you identify the important words, these are the independent dimensions, and then you get a vector for the text.
Yes.
How do you get the vector for a word, for a single word?
Well, the simple answer is I use it as a library and then type it in, and then it appears. But you're right.
Actually, it may build already important semantics in that mapping.
Yeah.
Right? It does.
And yeah.
It works actually by abstracting in a couple of steps down from the concrete complex. So you always take, for every word, you take like the 2 or 4 preceding and the words after it. Then you map all of these words into one representation. And you have a representation for the word from that particular context. You do that over every context, like 500 times, occurs 500 times. And then try to find out which dimensions you got from that, which are the ones that discriminate best. So which are the ones which determine the difference to other words in the best way. This is like typically in multi-layer abstraction.
So
the idea is to minimize the dimensions that you're actually going to use.
Yeah. Okay. So assume that this works well, and then when comes is this the deep learning? What you are saying? Or
So the idea is to use deep learning to determine.
So the deep learning defines that vector space model.
Yeah, exactly. So basically, you have a neural net that maps your in the end maps your words to
have explicit dimensions. So you do not say this is one feature and this is not, but you let the net learn the features.
So in many ways, this is very similar to dimensional reduction in machine learning. So in machine learning, you have a long vector, but if you use the long vector to...
Well, but in dimensional reduction, somehow you have some math that tells you, oh, that dimension is not good, or does not tell me anything, so get rid of it.
Yeah.
But you have to teach your deep learning network something, and I don't get what you teach.
Yeah.
Just teach texts, like how
Well,
are words distributed.
Yeah. That's how it works. Okay, any more further questions on that? Yeah, so is that that's one of your slides?
You already said that.
Oh, okay.
So it's just it's not perfect what you get out of querying the word-to-vec model.
Yeah.
So you have to do manual refining.
Exactly. And again, we need to see if the word-to-vec is even useful. We need to evaluate that before we can, it's just a thing that we really want to try because we think it's very interesting to see if these sorts of things work. Also with regard to query expansion in general. So if we see that it works very well, then maybe we can even automate. Okay, so next thing, detecting work mentions. We already saw the examples here, and I just highlighted 2 things. So ideally, we make something like a connection between the work and the work mention and the actual semantic field. So in this case, what we're looking for is Symphonia Eroica. And finding that one is pretty simple because we can have just a list of work names and just pick out if it's on the list, and then we have it basically. But in many cases, it's much more difficult because we have to take a lot of background information into account. For example, Mendelssohn's Symphony No. 5. Mendelssohn was not the only one who ever wrote Symphony No. 5, so we have to look a bit around and make some kind of inferences if we can. So here it only says the composition, and we need to also to use co-reference resolution to see what that actually refers to. Because what we do not want is to attach a semantic field to the wrong work mention, because then our whole model screws up. Okay, so how do we do that? It's basically an entity recognition, named entity recognition task. We have to identify. We start with a list, so we first have to look at what kind of knowledge bases we can use and leverage, a list of names and pieces that we already have, and then from there we get something like a training set to see in which kind of context such a piece might occur, and then what we're trying to do is to find these linguistic patterns that we have a very good clue if what they're talking about there is a piece of music. And then again, we can use machine learning if we want to refine that even further. So to go from pure pattern thing to something more sophisticated like traditional random fields. And again, we need to use some sort of annotation so that we can evaluate the whole thing. That's for the entity recognition, and get back in for the semantic search. Yeah.
Yeah, it's pretty easy to make it quick because, as I said before, once we have the information on the semantic fields, we have something that we can search for. The idea is to do query expansion, basically. So if you search for one word, you can search for all members of the field that this word is a member of.
And this is where my question comes in again.
Yeah.
If you mix different languages, you can optimize the query by peeling off the languages that does not belong to the language of the text. Because otherwise you put much more matching burden onto semantic, onto Elasticsearch.
Yeah, but it actually depends on how you use Elasticsearch. So you can have 4 separate fields, or you can put in one field and then you can search it, and the company names and works different things. But that's basically it. So it's just use Elasticsearch and do query expansion by defining this synonym token filter, where you just put in your semantic fields or your semantic fields, those clusters. So this is actually all that you do. And when you do that, then you get lots of results. But once we have the annotations of this piece of text contains the concrete work mention, then we can just filter it by having those work mentions on top. So you don't have to look at all your complete recall, for example, but you just have to look at the top ones. And then you can start with your manual again, the manual work in analyzing. Okay, and in the end, once we have all that, we have that corpus of musical experiences, searching it, then the musicologist can systematically go for analyzing the compositional patterns. And then we have the connection between compositional patterns and those expressive qualities. So this is kind of the method that we are working on, which would be something like this workflow. So we generate those semantic fields, and then they have to be refined a bit. Then we can identify those work ranges, and then we bring it both together in some kind of semantic search, which is tailored to this problem. So it's not a general approach in that sense. So it's just tailored to this problem. If we have that done, we think we have access to the relation between compositional patterns and specific expressive properties. So that's actually the benefit from our side, or why digital humanities makes sense in this context, is like we can give better access because we can give more access to all those texts, and once we have that, we can quantify about those expression types. So this is actually what we do. Let's give the extension and do that next year. So, thank you.
Thanks a lot. It's almost 4:30, but maybe 1 or 2 questions are possible. If there are any.
I'm a bit astonished that entity recognition is here seems to be a problem here, because usually musical pieces are rather well structured in their reference. I mean, you have a composer, you have the title of the work, you have even the Köchelverzeichnis numbers, stuff like that. So I would assume, as a naive outside watcher, that this is the most, the perfect space where you can very easily identify it.
I would expect that too, but it's
Maybe it's my But things like the Köchelverzeichnis are much later, they didn't exist then.
Okay.
So they are mentioned. And for example, Mozart, but a better example would be Haydn. He wrote like more than 100 symphonies. So there are several in the same key, like D major symphonies, and there's hardly a way how to recognize what it might be. And the word like symphony occurs so often in the texts that you have somehow to figure out what kind of symphony it might be. It's actually very difficult to define features that make it obvious.
But I would assume that every article, I mean, you are extracting the information from magazines, basically, from journals and so on.
Yeah.
So they are properly titled. So this text refers to this piece of this composer in this key, and this is the title and so on. And then, then I have the perfect reference.
Yeah, sometimes they do, but then it's like, this is about Haydn Symphony in D. Very often you don't get more, but more often you get reviews of concerts where they would tell you, well, we heard works by Beethoven, by Brahms, by Wagner, whatever, and at some point we mentioned we had the symphony in E flat by Beethoven also, and So it can be, it's usually much more complicated than such an easy information, unfortunately.
And also the interesting part is that the information is, we looked at some examples, so sometimes the information is spread over different sentences. So we can just find this place, but you have to look at different information and combine them together.
Good question.
Yeah, so you're looking at the context of the text itself, but do you also have to consider the temporal context of the time? I mean, if you have a really long time span, I can imagine that some words might change their meaning.
Yeah, it's perfectly true. We would have to do that, but the first step, we just need access to the corpus as a flat corpus. So we just treat it as being one time span. So just one time. But you're perfectly right. I mean, semantics involved, but to show that, we would have to choose another setting, which is what I just skipped. This one. That's where Funk comes in, where we need something like a slider, where you can say, okay, this is the meaning of word X at a certain time, because this is the distribution of pattern then. Then if we go 100 years later, the meaning is completely different. So this is actually what we refer to, and normally I would say yes, we'd have to do that. But in the first step, it's okay to just treat it as being the same. So it's just a generalization. You're right.
I think we should stop here and allow for the coffee break. Thank you very much.
Thank you.
Again.